Hello to everyone. I am Professor Raja, working as Assistant Professor, ECE Department, SNS College of Technology, and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss about 23 ECET 221 Microprocessor and Microcontroller subject under the topic 8255. In my previous YouTube video, I given a basics and spins and signal working of Programmable Peripheral Interface, that is 8255. Now in this video I am going to discuss about a detail about how individual parts in 8255 is working. So if you see this diagram, data bus buffer are already discussed. Now I am going to discuss what is this purpose of this read write control logic, what is the purpose of this group A, group B, then how this port A, port B, port C are selected based on the given condition from group A and group B. Now I will start this video. So if you see this figure, 8255 consists of 4 important blocks. One is data bus buffer, second one is read write control logic, third one is group A, group B control, then fourth one is port A, port B, port C. So these are given as this diagram. So it has a 40 pin of 4 parts. First part is data bus buffer, second part is read write control logic, third part is group A and group B control, then the fourth part is port A, port B and port C. Now data bus buffer, this is a tri-state bidirectional data bus buffer used to interface the 8255 to system data bus. Data is transmitted or received by the buffer on execution of input or output instruction by the CPU. Read write control logic, this unit accepts control signals RD, WR and also inputs from address bus and issues commands to individual group of control blocks, group A and group B. It has a 6 pins CS bar, RD bar, WR bar, RESET, A1 and A0. Group A and group B controls. These blocks receive control from the CPU and issues commands to their respective ports. Group A, port A fully and port C upper part. Group B, port B fully and port C lower part. Now port A, this is the 8-bit latched buffered output and 8-bit input latch. It can be programmed in 3 modes. One is mode 0, second one is mode 1, third one is mode 2. Port B, it can be programmed to operate in mode 0 and mode 1. Port C, this can be programmed to operate in mode 0 mode. This is the structure of control word register. Now we can see individually how these modes of operation are conducted by 8255. So bit set and reset mode. This bit set and reset bits are used in port C port. Input output mode, that is in 3 types: mode 0, mode 1 and mode 2. Mode 0 means simple input output working mode. Mode 1 means handshake, that is it can provide the acknowledgement to the input. Then mode 2, bidirectional data transfer. The next, this is called the BSR mode, where BSR mode means it is a bit state and reset mode. So based on this B2, B1 and B3, we can choose the port C to port 7. Next, second mode is called input output mode. Simply it is the input output mode or mode 0. Port A and port B are used as simple input output ports. Port C has 2 4-bit ports. The main features of this input output mode are: outputs are latched, inputs are not latched, ports do not have handshake or interrupt capability. Then mode 1, input output with handshake mode. Handshake signals are exchanged between microprocessor unit and peripherals. The features of mode 1 are: port A and port B are used as simple input output ports. Each port uses 3 lines from port C as handshake signals. Input and output data are latched, interrupt logic supported. Next is mode 2, bidirectional data bus buffer, used primarily in applications such as data transfer between 2 computers. The main features of this mode 2 are: port A can be configured as the bidirectional port, port B in mode 0 or mode 1. Port A uses 5 signals from port C as handshake signals for data transfer. Remaining 3 signals from port C are used as simple input output or handshake for port B. So thank you for watching my video. In this YouTube video, I discussed the main purpose of 8255 and how individual parts in 8255 are working. In the next YouTube video, I am going to discuss about some serial communication interface. Thank you.